Good morning to all the students. Today we will discuss the last article from the biasing circuit, that is called as the voltage divider or the self-biasing circuit. This circuit is the very important circuit and it is widely used circuit because it has the very high stability of the operating point. Clear? So firstly we will draw its circuit diagram. So what we have, we are using here PNP transistor. So this is the PNP transistor. This is PNP, and this transistor is in the common emitter mode. Clear? So already we have discussed this is VCC power supply, and this resistance is what? This is a resistance RC, which is connected with the collector part, and we have one more resistance which is connected towards the emitter side, and it is called as the RE resistance, and we have one more capacitor which is CE, which is connected in the parallel connection to the resistance RE. Clear? And this is earth. So now here we are having one more capacitor. This is C2 capacitor, and we are taking the output from here, and this is the output portion. Clear? This is the VO. So if we define here this point, this is the potential VE, which is the potential across RE, and this is the potential difference, and यहाँ पे बच्चों हमारे पास है collector and this is emitter, so this is what? This is VCE. And in the left hand side, what we are having, earlier we are using here only one resistance, but now we will use here two resistance. So these two resistances are used for the voltage divider circuit, and which is called as the voltage divider arrangement. So we have two resistances like this. This is a resistance R1 and this is a resistance R2, and we are having capacitor C1, and this is the input portion. So the input here is VI. Clear? So this is the complete setup for the voltage divider circuit. So in this case, this VCC supply is distributed among the R1 and R2. So the net potential across R1 and R2 is what? This is VCC. So voltage across R1 plus voltage across R2. So these are the very important points. Suppose the current flowing through the collector is IC, and the current across the resistance RE is IE. This current is IE. Suppose this current is IB. Okay, so this current is IR2 and this current is IR1. We know that if IB and IR1 is going in this way, so if we are applying here the junction rule, so what I can write down, IR1 is simply equal to IR2 plus IB, and we know that the value for the IB is very small. यहाँ पे हम लिखेंगे, we know that IB is very small. So तो हमारे पास यहाँ से क्या है बच्चों? So IR1 is numerically equal to IR2. Clear? So now what we are doing here? So again we are suppose this is equation number 1. So recalling equation number 1, what I can write down, VCC, which is equal to VR1, voltage across R1 plus voltage across R2. So what is the voltage across R1? This is simply IR1 into R1 plus IR2 into R2. Clear? So if we want to calculate here the value for the current I1, now we will find out here the value for current IR1. So what is the meaning for this current IR1? So if we are looking here, this current IR1 is simply equal to current IR2, and VCC is simply your IR1 into R1, and I can replace this IR2, which is simply your IR1 into R2. And if we common IR1, so ब्रैकेट में आएगा R1 प्लस R2. तो हमारा IR1 क्या हुआ बच्चों? दिस इज व्हाट VCC divided by R1 plus R2. So we have this amount of current which is passing through the resistance R1. So now if we are writing voltage across R2, so what is the voltage across R2? This is VR2. VR2 is what? This is IR2 into R2. And what is IR2? We have seen that the value for IR1 is numerically equal to value for IR2. So I can replace here what I can write down. I can write down IR2 into IR1 into R2. तो हमारा बच्चों VR2 क्या बना? This is what? VCC divided by R1 plus R2 into R2. So this is what the voltage across the resistance R2. So now moving to the next slide, what we can write down here using loop rule in the input side, input section. So we will use here the loop rule in the input section. So if we are writing here the loop rule for the input section, what I can write down? That I can write down this VR2. VR2 is basically the voltage across R2. This is simply equal to voltage across VBE, base emitter voltage, plus voltage across emitter RE. Clear? So I can write down here VR2 is simply equal to VBE plus VRE. So ये मैंने कैसे लिखा बच्चों? This is the R2. इसके सामने हमारे पास दो चीजें हैं. This is what? This is VBE and second portion is the potential across RE. So it means that तो मैं यहाँ पे लिखूंगा voltage across R2 is equal to VBE plus voltage across RE. And अगर मैं इसको डिटेल में लिखूं, what is the voltage across RE? This is IE into RE. So this is what? This is VR2. So rewriting this equation, so VR2 is simply equal to VBE plus IE into RE. And यहाँ से बच्चों अगर हम कैलकुलेट करें द वैल्यू फॉर IE, तो ये क्या आएगा? दिस इज इक्वल टू VR2 minus VBE divided by RE. So this is the value for the ammeter current. So we will note down this value, and now using the loop rule in output section. So if we are using the loop rule in the output section, so what I can write down? Again, we will check the output circuit. In the output circuit, what we are seeing, we are having VCC and this is ground. और इसके बीच में हमारे पास क्या तीन चीजें हैं. We are having RC, VCE and VE. So when the current IC will flow through the resistance RC, so the potential drop is IC RC. And this potential is VCE between collector and emitter. And the voltage across the resistance RE is VE. So I'm writing the equation. So VCC, which is equal to IC RC plus VCE plus the last component is VRE. And अगर हम VRE लिखें, so this is what? This is IERE. Clear? So by substituting the values, so VCC, which is equal to IC RC plus VCE plus IERE. And also, what is IE? IE is basically IB plus IC. And again, the value for this IB is very small in comparison to IC. So we can write down this IE is numerically equal to IC. तो हमारा ये इक्वेशन क्या बनेगा? दिस इज VCC which is equal to IC RC plus VCC plus this IE is now IC. So this is IC RE. So if we are solving this equation for the IC, तो हमारा IC बच्चों क्या आएगा? This is equal to VCC minus, sorry, this is VCE. So this is VCE divided by, from these two components, IC is common. So we will divide by RC plus RE. So this is the value for the collector current, which is the IC value. And this value for IC depends upon the value for VCC, which is fixed, RC again fixed, RE, this is also fixed, and it depends upon VCE. The operating point in this case will not shift by the replacement of the transistor with a new transistor, because the value for VCE, in this case VCE is independent to beta, which is the value corresponding to the new transistor. So it means that if we are changing the transistor, the value for VCE will not change, and therefore the value for IC will not change. It means that this IC is fixed. So now we will learn how to find out the stability factor in this case. So next slide is formulation for stability factor. Students, now we will discuss about the stability factor. We have already seen what is the stability factor. This is curly IC by curly ICO. And in the previous lectures, we have seen with the variation in the IC, the leakage currents increases, and due to the increase in leakage currents, collector current will increase, and we have ultimately a condition of thermal runaway. So now in this case, we will check whether the stability exists in this case or not. Clear? So as the temperature increases, so we have seen in the previous article, as the temperature increases, which one factor increases? ICO increases. ICO is what? These are the leakage current. और जैसे ही बच्चों यहाँ पे लीकेज करंट इंक्रीज होगा, हमने एक इक्वेशन सुनी थी, IC इज व्हाट? दिस इज बीटा IB प्लस 1 प्लस बीटा ICO. सो एज द ICO इंक्रीजेस, तो हमारा कलेक्टर करंट क्या होगा? इंक्रीज करेगा. And also we have what? IE is what? This is simply plus IC, and IB is very small in comparison to IC, and this IE is nearly equal to IC. तो जैसे ही हमारा IC बढ़ेगा, तो हमारा IE वाला फैक्टर भी बढ़ जाएगा. As IE increases, तो ये वाली इक्वेशन जो है हमारी, हम देख सकते हैं IE RE, this is what? Potential drop across RE, and it depends upon the value for emitter current. As the value for emitter current IE increases, तो हमारा क्या होगा? IE RE इंक्रीज हो जाएगा. और जैसे ही हमारा स्टूडेंट्स IE RE इंक्रीज होगा, तो हमारा जो ये IE RE इंक्रीज होने से जो हमारा VBE है वो कम हो जाएगा. फ्रॉम दिस इक्वेशन वी कैन ऑब्जर्व दैट as VR2 is simply equal to VBE plus IE RE. Clear? So therefore this base emitter जो biasing है that decreases. जो हमारी base emitter biasing है बच्चों, ये क्या कर रही है हमारी? This is the forward biasing. So what will happen? So the forward biasing किसकी? ऑफ बेस एमीटर जंक्शन डिक्रीजेस। और जैसे ही हमारी बेस एमीटर जंक्शन की फॉरवर्ड बाइसिंग कम हो जाएगी तो हमारे पास क्या होगा? जो हमारा आईबी करंट है वो कम हो जाएगा। अगर स्टूडेंट्स हमारा आईबी करंट कम हो गया तो यहां से हम इक्वेशन से देख सकते हैं, जैसे ही हमारा आईबी करंट कम हुआ तो हमारा आईसी करंट भी कम हो जाएगा। मतलब टेम्परेचर बढ़ने से जो हमारा लीकेज करंट बढ़ा था उसने हमारा आईसी करंट बढ़ा दिया था। ये वाला फैक्टर हमारा ज्यादा हो रहा है और ये वाला फैक्टर कम हो रहा है। तो अल्टीमेटली जो हमारा आईसी comes to original value. IC comes to original value. तो इस तरह से जो हमारी IC की वैल्यू है that is stable with respect to the change in the temperature. So हमारा जो स्टेबिलिटी फैक्टर है यहाँ पे काफी हमें अच्छा दिख रहा है, हमारा ऑपरेटिंग पॉइंट है जो स्टेबल है. So the operating point is stable with respect to the variation in the temperature. So now next we will calculate the value for stability factor, and we have defined in the previous articles also what is the meaning for the stability factor. This is simply I curly IC by curly ICO, means the variation of collector current with respect to the change in the leakage current. So in order to discuss, so मैं यहाँ पे heading बना लेता हूँ stability factor. So in order to simplify and to calculate the stability factor for this voltage divider biasing arrangement, I will just draw my diagram. So this is the PNP transistor in the common emitter mode. Clear? So this is the resistance RC, and we are using here one more resistance connected to the emitter terminal, which is the RE, and this is the capacitor CE, and this is RE. And this, we will just modify this diagram, and we have connected this RC with the VCC supply with its negative terminal. So this is the VCC component. Okay, and on the left hand side we will draw its equivalent circuit according to the Thevenin theorem. So I will just replace this R1 R2 by the net resistance, which is called as the Thevenin resistance, and I will replace with the source, which is called as the Thevenin voltage source. So what we are doing here, we are just attaching one resistance which is the equivalent resistance. So this RT is basically what? This is R1 R2 divided by R1 plus R2, and we have a source which is called as the Thevenin voltage. So this is the circuit, and this voltage is the Thevenin voltage. And what is the meaning for this Thevenin voltage? The voltage across the R2 resistance is corresponding to the Thevenin voltage. So what is the voltage across the R2 resistance? So I am writing here, I have written this is the voltage across the R2 resistance. So what is the Thevenin voltage? This is the voltage across the R2, which we have written earlier. So this is VCC into R2 divided by R1 plus R2. Clear? So now we will just solve this circuit, and we will check what is the meaning for the stability factor. So this VT is what we are looking for, the Thevenin voltage. So this is equivalent to this the potential across this RT plus the potential across the resistance RE. So this voltage is again VBE. This is the again voltage component between the base and the emitter. So what we are writing here, this voltage, Thevenin voltage, is equal to the voltage across RT, which is the Thevenin resistance, plus VBE plus V across RE, We have already written what is the V across RE. This V across RE is simply equal to IE into RE. Clear, students? Similarly, what is the voltage across this resistance RT? So this is the base terminal and the current flowing through this base terminal is IB. So V of RT is what? This is IB into RT. So I am writing these values. VT is equal to VRT बच्चों हमारा क्या है? This is RT into IB plus BBE प्लस VRE है हमारा IE RE, और IE को हम क्या लिख सकते हैं? दिस इज सिंपली IB प्लस IC into RE. क्लियर? सो दिस इज व्हाट IB RE प्लस IC RE. क्लियर? तो यहाँ पे हमारे पास दो फैक्टर्स हैं IB के, तो इनको हम एक साथ लेंगे और बाकी सभी फैक्टर्स को दूसरी साइड शिफ्ट करेंगे. तो हमारा IB क्या आएगा? दिस इज VT माइनस VBE, ये वाला फैक्टर, माइनस ICRE, दिस वन ICRE, और डिवाइड में क्या आएगा बच्चों? नीचे हमारे पास क्या आएगा? दिस फैक्टर और ये वाला फैक्टर. इसमें से IB अगर कॉमन आएगा तो हमारे पास नीचे बनेगा RT प्लस RE. क्लियर? तो हमारे पास दिस इज द फॉर्मुलेशन फॉर IB, एंड ऑल्सो वी नो दैट हमारा IC क्या होगा? दिस इज बीटा IB प्लस 1 प्लस बीटा IC हो. तो अगर हम यहाँ पे IB की वैल्यू रख दें तो हम देखेंगे हमारा फॉर्मुलेशन क्या बनेगा. तो हमारा IC इज व्हाट? दिस इज बीटा इंटू IB हमारा है VT माइनस VBE माइनस ICRE डिवाइडेड बाय RT प्लस RE, और साथ में बच्चों हमारा आया 1 प्लस बीटा ICO. क्लियर? तो अगर हम इसको बच्चों सॉल्व करें, हम IC के फैक्टर्स एक तरफ ले लें क्योंकि हमें चाहिए करली IC बाई करली ICO, एंड बाकी सभी फैक्टर्स को हम दूसरी साइड ले लेंगे. तो IC वाला फैक्टर एक तो हमारे पास यहाँ से आ गया, एक IC वाला फैक्टर यहाँ से आएगा. ये नेगेटिव है, दूसरी साइड जाके ये पॉजिटिव हो जाएगा. तो हमारे पास बनेगा बीटा RE IC divided by RT plus RE, which is equal to beta VT minus VBE divided by RT plus RE plus 1 plus beta into ICO. और अगर हम यहाँ से बच्चों IC कॉमन निकाल दें तो हमारा क्या बनेगा? दिस इज 1 प्लस बीटा RE डिवाइडेड बाई RT प्लस RE. तो हमारे पास कुछ इस तरह के फैक्टर आएगा. तो इनको मैं एक बार फिर से लिख लेता हूँ नेक्स्ट लाइन में. सो व्हाट वी आर हैविंग RC इंटू 1 प्लस बीटा RE डिवाइडेड बाई RT प्लस RE is equal to beta into, so what we are having, VT minus VBE divided by RT plus RE in plus 1 plus beta into ICO. तो अगर हम IC की वैल्यू निकालें तो हमारे पास बनेगा बीटा इंटू VT माइनस VBE डिवाइडेड बाई RT प्लस RE, और ये वाला सारा फैक्टर मेरा नीचे आ जाएगा. सो दिस इज 1 प्लस बीटा RE इंटू RT प्लस RE प्लस 1 प्लस बीटा ICO डिवाइडेड बाई 1 प्लस बीटा RE डिवाइडेड बाई RT प्लस RE. तो अगर इस इक्वेशन को बच्चों हम डिफरेंशिएट कर दें, डिफरेंशिएट किसके अकॉर्डिंग? विद रिस्पेक्ट टू ICO. तो हमारे पास क्या बनेगा? करली IC बाई करली ICO. तो हमारे ये वाले फैक्टर में बच्चों ICO के कंपोनेंट्स नहीं है तो ये 0 आ जाएगा, प्लस इसमें हमारा ICO है तो ये बनेगा 1 प्लस बीटा डिवाइडेड बाई 1 प्लस बीटा RE divided by RT plus RE. And this is what? This is the capital S. तो हमारा कैपिटल एस क्या बना? दिस इज 1 प्लस बीटा डिवाइडेड बाई 1 प्लस बीटा आर ई डिवाइडेड बाई आर टी प्लस आर ई. तो हमारे पास कुछ इस तरह का अरेंजमेंट्स बना. और अगर बच्चों हम यहाँ पे ले लें, इफ वी हैव फॉर बेटर स्टेबिलिटी, अगर हम ले लें फॉर बेटर स्टेबिलिटी, अगर हम देखें आर टी इज वेरी स्मॉल इन कंपेरिजन टू आर ई, तो हम ये आर टी को निगलेक्ट कर देंगे. तो एस हमारे पास क्या बनेगा? 1 प्लस बीटा डिवाइडेड बाई 1 प्लस बीटा आर ई डिवाइडेड बाई आर ई. तो ये आर ई कैंसिल हो गया बच्चों. दिस इज 1 प्लस बीटा डिवाइडेड बाई 1 प्लस बीटा. तो ये 1 प्लस बीटा कैंसिल, हेंस द आंसर इज 1. तो 1 स्टेबिलिटी मतलब इसका जो बीटा है, सॉरी एस की वैल्यू है, दैट इज मिनिमम, एंड द मिनिमम वैल्यू फॉर द स्टेबिलिटी फैक्टर इज 1. तो इसकी जो स्टेबिलिटी है बहुत ज़्यादा होगी. तो इसलिए ये हमारा काफ़ी इंपॉर्टेंट सर्किट है. तो दिस इज द एंड ऑफ द बाइसिंग अरेंजमेंट्स. तो इसके बाद हमारे बच्चों कुछ आर्टिकल्स हैं बच्चों एच पैरामीटर के, वो करेंगे हम.